The concept of significant figures seems pretty straightforward, but is one of the most deceptively complex topics in chemistry. And almost all of the confusion revolves around just one digit, the zero. Take it from someone who's been teaching chemistry for over 30 years. Significant figures are not to be underestimated. Hi, students. My name is Professor Waugh, and this is the second part of our significant figure series, where we'll go over the last two significant figure rules. They both involve zeros. All right, let's start class. All right, let's get into rule number 4. You see all the stars around rule number 4? This is the one rule that students miss a lot, but I know you won't. I have faith in you. Zeros behind the decimal point and at the same time after a significant figure are significant. So both things have to happen. You have to have the zero behind the decimal point, and you could have to have it after a Sig Fig. And I don't care which one comes first, the decimal point or the Sig Fig, or the Sig Fig, then the decimal point. But both things have to happen simultaneously. All right, let's get into an example. So I've got the first example is 7.0000. I think there's 4 zeros, meters. The little m is meters, and that is a total of 5 Sig Figs. Why? Because all of those zeros after the decimal point, after the Sig Fig, are significant. They are giving us the precision of the number, and the more digits after the decimal point, the more precision you have, right? All right, now you know how to put this in scientific notation, that I could take that number 7.0000 and multiply it by 10 to the 0 meters. 10 to the 0 is the same thing as 1. So that's how you would write that number in scientific notation. Let's do another example, okay? So if I gave you the example of 0.002060 liters, remember liters is a volume, and that's a capital L now. Those beginning zeros are not significant. That was the previous rule, rule number 2. But that 0 at the end and the 0 right after the 2, they are significant. The 0 after the 2 is trapped between 2 Sig Figs, right? And the 0 at the end is significant because it's after a Sig Fig and it's also after a decimal point at the same time. So we have a total of 4 Sig Figs. So in scientific notation, we look at the original number, you see that it is less than 1. So then all we have to do is bounce that decimal point behind the 2, after the 2, and then we just write it out as 2.060 times 10 to the negative 3 liters. Now remember, because the original number is less than 1, your power of 10 has to be a negative power of 10. And don't forget my units. All right, let's keep going. All right, let's do rule number 5, trailing, which means ending zeros. Now, trailing or ending zeros are not significant unless there is a decimal point at the end. All right, now some instructors like to use this and some instructors don't, but don't forget that is a rule, that trailing zeros are not significant unless you have a decimal point at the end. So let's look at some examples. We have 200 liters, capital L means liters. There's no decimal point in that. Do you see that? So that means we only have 1 Sig Fig versus 200 decimal point liters. That decimal point at the end says to me that those zeros are significant. So in that scenario, we would have 3 Sig Figs. All right, now putting it in scientific notation, if the zeros are not significant, we don't need to see them, okay? So for the 200 liters, we'll put that in scientific notation as 2 times 10 to the 2 liters. That's a less precise number than looking at 2 times 0 times 10 to the 2 liters. Do you see the difference? You have more precision in 2.00 times 10 to the 2 liters. That's very important in chemistry, so pay attention, okay? Thank you for attending class. To recap, we went over the last 2 significant figure rules concerning zeros. The first rule being that zeros behind the decimal point and at the same time after a sig fig are significant. It is very important to remember that at the same time, since that's what trips up a lot of students. The last rule is a rule that not every teacher follows, so remember to ask your professor before committing it to memory. It states that any trailing or ending zeros are not significant unless there is a decimal point at the end. Okay, now with this and the last video, you have all the rules for non-exact numbers, but we're not done yet. In the next video, we're going to go over the Sig Fig rules for exact numbers. So stay tuned. Once again, thank you for watching. We are a friend in chem, and our mission is to help students learn introductory chemistry. Our email is in the description, so if there's any way we can help you, please contact us. We want you to be successful in chemistry, enjoy chemistry, and have fun with chemistry. Until next time, take care.